Okay, so let's go over the notes from page 632 and 33. Sorry that we ran out of time in class, but we are going to find out how to find the sum of a geometric sequence. And the important formula is this one right here. So the sum of the first n terms of a geometric sequence is this right here. This is the formula that we need to know. And let's hop right in and do example 6. So example 6, they've given it to us in sigma notation. Notice to use the formula, we need to know what is a sub 1. So a sub 1 occurs when I is equal to 1, 1 minus 1 is 0, anything to the 0 is 1, so 4 times 1 is 4. The r in a geometric sequence from this notation here, the r is what's always in the parentheses. It's the base of the exponential part. So r is 0.3, and n from 1 to 12, that's 12 terms. So now let's go ahead and put everything in here. So we have a sub 1 is 4, 1 minus 0.3 to the n, all over 1 minus 0.3. Now notice this looks a little cumbersome with these parentheses, but plugging this into the calculator is oftentimes the hardest part. So let me try and do this here. So what we're going to do is we're going to have a 4 and then parentheses and then 1 minus and then 0.3 to the 12. Cursor over, and you have to close those parentheses. And then we will divide by parentheses 1 minus 0.3. And then enter, and we get 5.7. As you can see, that's what they have in the book as well. So practice that on your own. Make sure that you have the right calculator keystrokes there. Okay, and then the next important formula that we have, and the last for this, is the sum of an infinite series. Well, what does infinite means? It means it goes on forever. So if your terms are getting larger and if you graph them, they just got bigger and bigger and bigger, then there is no sum of an infinite geometric series. But if the absolute value of your constant ratio is less than 1, we say this series converges. It converges and it has a sum. And the beautiful thing about this sum is that it's so simple. This is the sum of an infinite amount of terms. Isn't that crazy? So let's go ahead and do example 7 here. So again, we're in summation notation. So we have when n goes from 0 to infinity, so we know from this that it's an infinite sum. And again, if n is 0, 0.6 to the 0 is 1. So 4 times 1 gives us a first term of 4, writing it over here. The part in the parentheses is our r, so 0.6. And then using this formula right here, the sum of all of these terms, they just use an s. Sometimes you'll see an s infinity, so you know that it's an infinite sum, is the first term 4 divided by 1 minus 0.6. That's it. Now when we go to figure it out, you must have parentheses around the denominator. So let's go ahead and do this. 4 divided by parentheses 1 minus 0.6, and we get 10. That is the sum of all of the terms that go on infinitely long. Okay, just make sure that you have to test your r. If r is greater than or equal to 1, the series does not have a sum. It can be negative, but the absolute value must be less than 1. Okay, one last quick check, your checkpoint. Right here, I'd like to do one where they just give us the terms of the geometric. Well, is it geometric? Let's see. We have 5 plus 1 plus 0.2 and so on. Remember, the way that we find the r is to take any term and divide it by the previous term. So that would be 1 divided by 5, or 1/5. 1/5 is the same as 0.2. 0.2 divided by 1 is 0.2. 0.04 divided by 0.2, you can check it. It should be 1/5 or 0.2, it doesn't matter. Okay, so now our first term is 5, so a sub 1 is 5. So now let's use the formula for this sum. The infinite sum is a, which is 5, all over 1 minus 0.2. And if we grab our calculator and plug that in, it would be 5 divided by, use parentheses, 1 minus 0.2. And our sum would be 6.25. Okay, I hope that helps. If you have any questions with your homework during the week, please feel free to give me a call or an email. Thank you.